Bueno, buenas tardes a todas y a todos. A nombre del Ministerio de Educación de Chile, de la Sociedad Chilena de Ciencia de la Computación y del Departamento de Informática de la Universidad Técnica Federico Santa María, les damos la más cordial bienvenida a este seminario. Quiero agradecer al profesor Dan García por haber aceptado nuestra invitación a estar aquí hoy con nosotros. Les recuerdo que pueden dejar sus preguntas en la sección de preguntas y respuestas, Q&A, de la transmisión. Voy a presentar a nuestro expositor. Dan García es profesor docente en el Departamento de Ingeniería Eléctrica y Ciencias de la Computación de la Universidad de California en Berkeley. Obtuvo su grado de BS en Computer Science en el MIT en 1990 y su máster en 1995 y el doctorado en el año 2000 en UC Berkeley. Fue elegido ACM Distinguished Educator en 2012 y ACM Distinguished Speaker en 2019. Ha ganado los 4 premios que reconocen la excelencia en docencia en su departamento y registra la mayor efectividad docente en varios de los cursos de ese departamento. El doctor García es uno de los líderes a nivel nacional en los Estados Unidos del movimiento CS for All, que busca atraer hacia las ciencias de la computación a comunidades de estudiantes que normalmente han estado excluidas de la disciplina. Gracias a 4 subvenciones de la National Science Foundation, el curso para no especialistas The Beauty and Joy of Computing, o BJC, del que es uno de los co-desarrolladores, ha sido compartido con más de 1000 docentes de enseñanza media. El curso ha recibido atención a nivel nacional en medios como The New York Times, PBS NewsHour y USA Today, así como primeras planas en el San Jose Mercury News y en el San Francisco Chronicle. Sin más preámbulo, dejo con ustedes al doctor Dan García.
Muchas gracias, gracias a todos. Let me share my screen fast and see if that works okay.
It's okay.
Can everybody see my screen?
Yes.
Wonderful. It's a delight and pleasure, un placer to be here today. I apologize for my my Spanish is not very good, but I can understand it, just not generate it very well. So I thank you all for letting me give this presentation in English, but we'll have some help with the Q&A to do some translation. If you want to ask a question in Spanish, that's fine. So thank you so much for this invitation. I want to talk about today's talk about fostering computational thinking in women through the Beauty and Joy Computing course that Heike helped co-invent, co-develop. This is the CS for All. We're part of the CS for All family, and this is our logo, the BJC with a smiley face, and this is me in the middle. My name is Dan Garcia. So lest you think that this is all my initiative, I work with many wonderful colleagues. My colleague Brian Harvey at Berkeley and Tiffany Barnes at NC State. We were the 3 faculty who led the grant writing for this, but we have a much larger team that help us put this curriculum and software together. June, Paul, Lauren, Michael, Mary, Salim, Jens, and Bernat, and the team actually continues to grow, but that was the team as of these slides. Some perspective. In 2012, this is 10 years ago, the U.S. high school AP enrollment, if we look at AP classes stand for advanced placement, and that means you're in high school, but you take a college class. So these are the number of students who were enrolled over the course of the year in these college classes. And you notice it's about 1 million people in history and English and science. It's about 750,000, and all the way down at the corner is computer science. Very, very small. And when you zoom in on that, you saw that actually it was not just small, but it would be fine if it were small but diverse. It was small and not diverse. In fact, computer science is one of the famous courses for having the worst gender balance in all of the advanced placement courses that they offer. So only 15% are girls or young women, and only 8% of students of color. This is in the US, where those numbers should be 50% and about 26%. So we're not doing well in terms of reaching students who traditionally do not get computer science. So there was an initiative by the College Board to create a new advanced placement course, again, a new course that'd be offered in high schools that would give you college credit. And the goals of that course were to make it engaging, accessible, inspiring, rigorous, to focus on the fundamental concept of computational thinking. The idea was that where most of these courses, you start by looking at the universities and you say, what is being taught at, let's say, Physics 1 at the university? And then you make a high school course that's mostly what's taught at Physics 1, where there really wasn't a course that was the equivalent of what's taught for non-majors. So we realized that what if we created an amazing course, maybe this would be an impetus, maybe this would lead the charge to have universities change their course. And so the idea would be this AP course or through the College Board would be a single source of national leverage in the United States. So thus began the process of creating the AP Computer Science Principles course. And I was part of the development committee, and the course was founded on 2 pillars. One pillar is 7 big ideas, the big ideas of computer science: creativity, abstraction, data and information, algorithms, programming, how the internet works, and global impact. But it's also, so that's what you know. The big ideas are what you're supposed to learn, but computational thinking practices are what you're supposed to learn to do. So facts are on the left and actions are on the right. And so these practices would be connecting computing to your interest and to other fields, creating artifacts, not just reading about them, but creating artifacts like programs, abstracting, how to make abstractions in your programs, how to analyze your programs. Maybe you wrote a function that only works for numbers when they're negative, or only works for things when they're perfect squares. That would be an analysis. Or it doesn't work once the size gets too big. Again, that's part of the running time analysis you would do, that we do in college too, but we would do this in high school. How do you communicate your results, and then how to collaborate? So this is a wonderful suite, and we spent a long time thinking about this and kind of refining what these look like. So we were really happy. We, the community, the computer science community, I think globally, really, we're happy with these 7 big ideas and 6 computational thinking practices. And they set out a call for many courses. If you wanted to be a course that could create a course, if you wanted to be a curriculum designer, to make a course that was going to be a computer science principles compliant course, meaning it's aligned with the AP, then they did that. And many people put courses together that did that. Some courses focused on mobile app design. Some courses focused on the facts of computer science, or kind of fluency. And we actually created a course. As I said, The Beauty and Joy of Computing is the course that UC Berkeley created, along with our friends at NC State, Tiffany Barnes. And what was special about our course was that it was a little bit more programming heavy. When we looked at our non-major, we had a non-majors course before. And what had made it successful, we would ask our students, what did you love about our old non-majors course? And they said, when you let me program, when we were actually doing it, not reading about computer science, but doing computer science. So it's about the programming that's really, really engaging. So for example, in other courses, you just read about how the internet works, or you watch a video. In our course, you write a code. You write a code that'll tap an API that'll actually play with the internet and program, and use some function that's in Japan or something. So we're a little bit more programming heavy. We also have these big ideas in computer science that no one else was willing to teach. So no one else really in the non-major space and in the computer science principles course space was willing to teach recursion. No one was willing to teach, or wanted to, not willing, but willing or wanted to teach procedures as data, otherwise known as Lambda. And really no one was teaching concurrency and distributed computing. So we said we need to teach these principles, not because we want to distinguish ourselves from the other courses, but because we were already teaching them to our own students and they loved it. We wanted to use a graphical language, so we picked Snap, or a Scratch variant. I'll get to that in the next slide. And we really wanted to make sure we talked about the ideas of the social implications of computing, and the social implications of computing get borne out or described in this wonderful book, Blown to Bits. So we had Blown to Bits, so delightful there. So we started from scratch. So a phrase, we start from scratch, is very funny. We actually did start from scratch. We looked at the Scratch programming language and we loved it, but it actually had a ceiling. It had a ceiling above us in which you could not write any functions. If you can't write a function, you can't use abstraction. You can't do that. So we started from scratch. Jens Monig was on the Scratch development team, and he had actually, he was a lawyer, but he's a programmer, in the evening. And so he hacked it together to add functions to that. And that began something called BYOB, which eventually became Snap, where you snap blocks together. And this is a picture of what BYOB blocks look like. So we leveraged how awesome Scratch is. Scratch is awesome. It has wonderful design, wonderful simplicity, a wonderful user community, and we wanted to kind of leverage that. It's written in JavaScript in the browser, so it's very easy for students to hack on it. It's open source, so you can grab it and make a modification to Snap if you wanted to. And I ask many of you on the audience, if a for loop, this is a for loop in Snap, how you would build a for loop in Snap. If your language did not have a for loop in it, could you build a for loop and use it as if it came part of the language? Well, here we are doing it in Snap. I'm making a for loop. For I equals start, the inputs are start, end, and some action. For I equals start, repeat until I is greater than end, run the action, change I by 1. That's a for loop. And here is, when you click this, you get this C-shaped block that treats itself just like a for loop and semantically does this, and it's going to have these double nested loops. It's beautiful. So can you do this in your language? Very few languages say that they can do that. So this is a very powerful. So Snap is not just a toy language for kids. It's a very powerful language that does things that many production languages can't do. Here's how we teach recursion. Again, most people don't teach this course. We teach it graphically. This is an activity from Paul Goldenberg, one of the faces you saw earlier. And this idea is, and I'll just describe what happens. This is the setup code on the left. You go to x is 0 minus 120. So put the sprite in the bottom center. This is a sprite-based kind of language. Each sprite is an object. And I'm asking that sprite to point in the direction 0, which points up. So this arrowhead is with the pen is right at the tip here. Hope you can see my cursor. To show yourself if you're hidden, to put the pen down, so there's a virtual pen at the tip of the arrowhead, to clear itself and call the V block. Well, what's the V block? Here's the definition of the V block. Here's the V block. Turn left 20 degrees, move out 25 steps, run item random of shapes. So this is the list of blocks. Look, it's a list. This is how you draw a list in Scratch. We decided, well, what if you wanted to have a block there? Well, this is the list of blocks. The idea that blocks can be data or functions can be data is one of our big ideas, and you can't do this in Scratch. So go out here and pick one of these blocks and run it, which means you do either draw a square or you draw a circle or you draw a triangle. Then go back 25 steps, turn right 40 degrees, which means you turn right 20, and do the same thing. Go out 25, run one of these shapes, and move back, and then do this. And let's try this. Here we go. And by the way, this is in Spanish, ladies and gentlemen. Snap can work in Spanish. Un aplauso, sábado gigante, un aplauso. So this is wonderful that this language can actually run in, it's at 35 different languages that you have. It's 35 different languages we support. And all I did was change the language and all the blocks translated automatically. That's amazing. So they have equivalent translations for all of the languages, for all the built-in blocks. Obviously, if you make your own blocks, like before I made, a circle, this is a square, a circle, and a triangle, I had to manually translate that, but you can do that as well. So if you're writing in Spanish, everything looks like Spanish. There's no reason you have to learn English to learn a programming language. Raise your hand if you know of a programming language that lets you program in Spanish. Anybody? No, right? Nobody has this. It's very rare to have a language where you can program in Spanish. By the way, I've gone around the country and around the world talking about this and giving this talk, and I go to China. Ladies and gentlemen, La Lengua China on Snap. And when I've given this exact talk in Chinese, they stand up and applaud. I didn't ask them to stand. They all simultaneously get up and instantly applaud the fact that they can actually program. Imagine people in Chinese don't even know the word for or while or if. Why are you teaching Chinese kids English words to program? That's crazy. This is literally all translated to Chinese. We're so proud of that. So anyway, it's wonderful to be able to work in a language and never have to see any English. Now, here's the catch. V doesn't translate. So I have to figure out what the word for V is in Chinese. But anyway, you have to do those things. So good stuff. All right. So we're back to and by the way, if I run the program, this is what you get. Look, here's what happens. It went here. It basically goes out, it makes a V. This is why it's called V. It's like the V, like the actual letter V. It goes out and picks one of these shapes and draws it at the end, and goes out here and picks one of these shapes, almost like on a Christmas tree. You have the little picture, the little shape at the end of a Christmas tree. So this is what happened when shapes is just square and circle and triangle. If I run it again, I get this. And it's not very interesting. This is a little boring. It just basically draws two different random shapes at the end of this little V. And I ask you, what happens? I wanted to ask all of you to think about this. what happens if in the list of shapes, I add V, itself. What is that? What would happen if I add V itself to the list of shapes that V could run? Remember, V is running. What V does is it turns and moves, and then goes to this list and picks a block and runs it. But what happens when V finds V? And then that V finds V. What would happen? Let's try it. Here we go. Let's run it together. Ready? 1, 2, 3. Well, nothing. That meant that every time I picked a random element of shapes, it's picking those green guys. It went out and picked the circle, which is a green one, and went out to pick the square, which is a green one. Okay? Let's run it one more time. And if you show this in front of students, they go all at once. And to say means that this is unexpected. The V went left, and when it went to here, it picked another purple V. And then that went left and right, it picked two green things. So eventually this is going to stop picking purple. So eventually this won't run forever. But it's really cool to have this. So let me actually show you what happens one more time. Ready? That's what happened. I didn't change the code. I just ran it again. And this is so beautiful. We talk about beauty and joy of computing. We think this output is beautiful. Look at this beautiful bush that was created. But it's not just the output is beautiful, but the code itself is beautiful. So the output, the pictures are beautiful, but the code itself is so elegant, is beautiful. And if I show you a couple different examples, here's 3 different runnings of this and how pretty this is when you run this. So it's really fun to run this live with students, and they just see, they go, whoa, look how pretty this is. It's very, very pretty, okay? So that's 3 different bushes you get from running V. So that's recursion. We teach recursion graphically. So we teach it using fractals. We teach it so that you can draw pretty pictures. And we talk about this would be really hard to draw. If you wanted to, you could code this iteratively, but it would be very hard. So we talk about the power of recursion, lets you draw these things with very little code. It's really beautiful. Now let me talk about abstraction, the most powerful idea in computer science, and why we talk about it. So this is a lecture, literally a lecture from my class. Why do we teach procedures? Because abstraction. So one student shows you this, and it's repeat 4, move 25, turn 90. What does that do? Oh, look, it draws a very little square whose side is 25. And then that same student has this piece of code in their workspace, in their script window. And what does this do? This draws a bigger square. And then they have this piece of code. And what does this do? This draws an even bigger square. And if some student came to you, if all the professors on this call, if a student came to you saying, here's my 3 programs, wouldn't you say, well, this looks like you're repeating yourself? And one of the phrases we have when we teach the course is DRY. Don't repeat yourself. No repite. Don't ever have code that does the same thing. Don't ever have code that does the same thing. So if a student came to me, I would say, you know what? You should probably put that in a procedure. Notice the only thing different between this code and this code is the number, right? 25, 100, 395. So that should be the input to a procedure. Draw a square of side length, and then that length is an input. And then when you want to draw any side square, you can put in 100, you can put in 4,000, you can put in 5, you can put in anything you want. So this is generalized 3 copies of code into one. You've now you've simplified your code. You now have exactly 1 block, and here's how you call it. And you just put in the number. That number gets length. This parameter gets bound to 100, and then whenever you see length, you use 100 as a variable, okay? As a formal parameter. All right. Well, people say, I get that. Thank you so much. And then I show this to college professors, and they don't have an answer for this. Then your student says to you this. They say, repeat 4, draw line 100, turn 90. This draws a square with solid lines. The next one is draw dash line 100, turn 90, and this draws a dash line square. And then they show you draw wiggly line 100, and this draws a wiggly line square. And I ask you, what would you tell the student next? This is where you might think about this for a second. What would a student do? What would you tell the student? Before we talked about don't repeat yourself. Don't have repeat code. Well, here I have 3 pieces of code in which they're almost identical, But what's different, rather than the different be the number, the difference is the green block. So now you're thinking to yourself, how do you collapse this into the green block is the thing that should be sent into the generalization? And many languages do not support this. So if people are learning how to program without a language that lets you pass in a procedure as data, you can't tell them anything here. You say, well, you have 3 copies of the same thing, but our language doesn't support collapsing that into one. But Snap does. I make a line drawing procedure, and this symbol of a lambda, of the Greek letter lambda, is how Snap is able to receive a procedure as data and then call it. We use the run block. You run the line drawing program with the input 100. So here's me passing in the wiggly line program. This function has a gray border around it, which means don't call it right now and try to draw a wiggly line with no size. There's no size here. That would be an error. No, it says this gray border says don't call it now, but package in the function as a function and pass it in here. And now this takes a function, which is why there's a lambda here. And then the way you call that function is you call the run block. And now I can draw any line drawing function, not just the draw line one, a dashed line, a wiggly line, but if I make up a new way to draw a square, I can now, or draw a line, I can now pass that in right now, like a Tiger Woods drunk. It can be a wiggly line, kind of drunk. You could draw that line where it's all wiggly and randomized. I can do that here as well. So I can pass in a block even without giving it a name as an anonymous function. Very powerful. So now I have a challenge for everybody on the call. I'm going to pause the lecture and I'm going to have everybody try to do this. So this is where we're going to wait and we'll take Q&A as your answer because there was no chat. So I'm going to give you and tell you what the challenge is, and I'm going to wait and we're going to go off on the side, go do, 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 while you're thinking about this, and I'm going to give you the challenge. Here we go. Let me just tell you what the challenge is. I want to double all your salaries. You're the manager of a company, and you have people who work with you, and you decide that you want to double their salaries. So you're going to write a function. You're going to write a function in any language that takes the input of a list of salaries. And in Snap, a list of salaries, here's a list of 3 elements. The salaries are 1, 7, and 12. Like maybe $1 an hour, $7 an hour, $12 an hour for 3 different people. And I want to double that. So the output is a new list. Not you're going to modify the existing list. You're going to return a new list of doubled salaries. So you're going to write a block called double salaries. It takes input a list of salaries. It returns, does not modify or mutate the original list. It's going to return a new list in which every number in the original list has been doubled. Okay? That's the challenge. And you can work in teams. So this is the challenge. I'm going to pause and I'm going to let people think about this. Maybe I'll give a full minute and I can play the do, 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 do right as we do this. Okay. But that's it. Everybody's about to do this right now. That's your job. My challenge for the whole audience is to do this. Can we all do this now? And I'm going to pause and let you all try to do this. Go. I'll even turn my video off and let you just go. Go ahead. Here we go. All right. So now I'm back. Did everybody have an idea, at least a sketch of it? I'm not sure if I gave enough time, but since I don't have any feedback from the students, what do you think, Federico, Pedro, Andrea? Should we more time or less time? What do you think? ¿Qué piensas? Keep going? Keep going? Okay. Keep going. I'm getting the signal. Keep going. All right. So if you were to sketch this, here's what most people do to sketch this. They write a for loop. Almost everybody writes a for loop. Here's how you'd write this in Snap. You make a variable doubled salary. This just makes a variable, doubled salaries. You initialize it to a new list. You do a for loop. For index is 1 to the length of salaries. So let's go 1, 2, and 3. This is going to iterate 3 times. And this is a wonderful block. It's like an array list. I can basically add something to the end of a list. It's very easy. You don't have to kind of pre-allocate things like in C or something. So this add block adds something to this existing. This list starts empty. There's nothing in this list. It's an empty list. And every time this add block is called, it's going to add something to the end of the list. What does it add? It adds the double of item index of salary. So it goes, when index is 1, it goes to 1. It grabs the 1. It doubles it, returns 2. It adds 2 to doubled salaries. Then it goes, index is 2. What's at the end? What is item 2 of salaries? It's 7. It doubles 7, 14. It adds 14. So it's going to do this 1, 2, and 3 iterations. And guess what? It works. Hey, it works. Woo. Okay, it works. Here we go. Nah, very, very happy that it works. Okay. Next. How about the next one? Doubled salaries using for each. Well, look at for each. What have we got here? So again, first 2 lines are the same. Doubled salaries, empty list. But for each is a little bit cleaner. I don't have to worry about the index anymore. Look, for each, it almost reads like a natural language. For each salary of salaries. And salary gets the value. You add double of that salary to doubled salaries. And now at the end of it, let's see, we go. And all right, here we go. Beautiful. That also works. Okay? So now you pause here and you ask yourself, can we do better? Can we do any better than this? Can we actually do any better than those 5 lines? I mean, can you get any smaller than 5 lines to do it? And I'll wait for a second while we think. Can you do better? All right. If we think about it, I think you can. Let's try it. 1 line. Snap is so powerful, you can do it in 1 line. And everybody else, every other computer science principles class is teaching 5 lines to do it. And BJC is teaching 1 line because the power of map. Map is a function that takes a function as data. You saw how to take a function as data before with the draw line. So map takes a function as data and a list, applies the function to every element in the list, returning a new list in which that function has been applied to every element. So here, 2, 14, 24, exactly as you want it to. And by the way, if you know Python, this is how you would do this in Python, how beautifully. So it's similar to what people are doing in Python with list comprehensions. So we're teaching this. We're teaching the beauty of map. Don't start to think about for loops. When you have some challenge, think about a 1-line map. Beautiful, very, very beautiful in terms of the elegance that you can do with your language. So that's my mini demonstration of what you can do with the language. Let's step back now and talk about some of the results we've had. So we did an analysis of the percentage of women. The talk about this is, engaging women in computer science. This is the percentage of women at UC Berkeley since recorded history. Only in fall of 93 or spring of 93 did Berkeley ever record the gender of their student. It's a little crazy. They didn't even know the gender before. They thought they were women, but they didn't know. They weren't surveying them. They just, you would enroll somebody named Susan or Claudia or something, but you wouldn't know whether it's a man or woman because you never asked them. So in 93, they started asking them, what's your gender? And we have the numbers for the women in our introductory computer science. This is the course for majors. So the bottom wiggly lines are the courses for majors. And notice they go up and down depending on whether it's the dot-com boom, the dot-com bust, but basically it's wiggling around 20% women. We're not doing very well. Sometimes it goes to 30, but not doing very well. This is our non-majors course. The non-majors course means you're not committing to be a computer science major. You just want to learn a little bit about computer science. And we taught a non-majors course in Scheme. We thought it was exciting and we thought it was fun. It was a text-based course. So all was text in, text out, no pictures, no graphics, no animation, no drawing. In that way, it was boring, but it was a beautiful, engaging, rich, kind of more mathematical course because it was very text in, text out. And that percentage of women was around 35%. Maybe you got to 40, even got to 45, but we never got to 50%. Well, we made a new course, BJC, and this is the percentage of women in BJC. And look at this. It's clearly a whole unit 10% higher than the other course. It was, by the way, we didn't just change the name, we changed everything. We made it about Snap, we made it about graphics, we talked about social implications of computer. We did a lot of changes. It wasn't just like we took the old boring scheme course. I thought it was interesting, but we took the old scheme course and just changed the name. We changed a lot of elements about it as well. But look at this, for the first time ever, we broke 50%. And we were so excited about that we actually had equal numbers of women and men in our computer science course. Amazing, we're so happy with this. Woo, so happy. So now, I then looked at the history and I said, I stopped counting in 2013. Did anything change? Remember, I've been teaching this for 10 years, this course. So how has this evolved over time? And I looked at it spring of 2018, 63% women. So now, it's so many women, we have to now have male outreach. We have to go to the dorms and say, hey men, come on, take computer science. It's going to be fun for you because so many women are taking, no, I'm joking. But my point is we could almost do this. This is amazing. So we were so happy with the percentage of women, and 63%, just delightful. And this is some of our women who come, take our class, and then become lab assistants, readers, and TAs, teaching assistants. One of the things that's amazing at Berkeley is there's a community and there's a culture of having students be part of the staff, the teaching staff. So these aren't my students, these are my staff. These are people who are my TAs, my readers, my lab assistants who have helped teach this course. Amazing when you are among 50% students and you look up and your TA is a woman and your grader is a woman. And it feels so engaging to be able to look up and see people who look like you. So we're really delighted about that. I wanted to step back for a second, talk about overall the advanced placement, what it has done for national computer science in the United States. So this is a total number of female students. Again, remember how few the number of AP students was, that young women were back in the day, and that number it was much lower than 15,000 taking the class, and then the number of percentage was back here 2012. Remember how low that number was? Thanks to both cultural interest in computer science and thanks to this course, the number has exploded basically. Look at this numbers of people taking this. And this is total students from underrepresented racial and ethnic groups. This is Black students, Latinx students, all taking it. Look at these numbers going up. And even better, if you look at the percent of female students taking this, this is going from 20, look at this, up to now 30 and better. We're kind of stabilizing at 30, so we need to keep doing work. We're not done yet, but we need to keep doing work to get it to 50. We're not going to stop until it's 50. We know that. That's very exciting. So but we've made some national progress in that. We, as was mentioned in my introduction, we have gotten some national press about this. So this is the front page of our local paper talking about our course. This is my student. She happened to have her feet up on the desk. I wish she didn't have her feet up on the desk, but she's sitting there in my class as the front page of computer science in my class. This was, remember I told you when we got above 50%, we got national press coverage. So this is TechCrunch talking about women outnumbering men for the first time in Berkeley's Intro to Computer Science course. This is Slate that picked it up as well. This is the Hacker News, which is very big, TechCrunch. This is the San Jose Mercury News. Here's me on the front page of the paper. So proud of this. And this is, again, another article of my students saying we need a moonshot to propel women into computer science careers. This was a really big deal, and we got national coverage for a little window in time. We were, we were very, very much focused, and our success was being highlighted. We also worked with teachers. We realized we can't stop at Berkeley. We have to go and do outreach with teachers. If you have something good at a university, you can't just keep it to yourself. You have to share it. You have to give it away to everybody. So we decided to get some funding from the National Science Foundation. They fund outreach activities like CS for All, and they gave us money to go around the country. This is the United States, and every computer here is where we went to. We would go to those places and have a session where we were offering computer science, a summer professional development workshop for teachers. And all the red dots are all the teachers that came from all around the country to go to our sessions. We were so happy. And we've reached 1,000 teachers. That's a lot of teachers to reach. We're very, very happy about this. This is an example of some of our teacher professional development. Here's me in the middle, sharing how much fun it is to learn beauty and joy computing with our teachers. So happy about this. This is going to Peru. We took our work to Peru, and these are students in Peru. This is Rafael, and this is Lara, and they gave a session to teachers and students to teach BJC in Peru. We were so happy about this. This is going to India. Here is me sitting in Pune, India, giving a session on this to 30 high school teachers from all around India who came. We were so delighted to do this. We also have our friends in Chile who have written to and worked with this. This is a wonderful engagement they have through their first year engineering course. We want to celebrate this partnership, celebrate the fact that they are part of our BJC family. We are so happy with their success in teaching this at their local university engineering course. Congratulations. We also wanted to reach, I'm from Nueva York, so I wanted to go back to New York and give back, and we got a grant to take the work to New York. Look at this representation. The demographics of students are 70% of Nueva York students are students of color. Just beautiful. So we were so happy to go to New York, the biggest school district in our nation. In the whole United States, this is the biggest school district in the nation. We were able to go there and show BJC, and we love this. Just love it, love it, love it. So very, very happy to do that. And thanks to that National Science Foundation grant. And I want to make sure that I mentioned that we partnered with EDC, who helped us develop the curriculum and helped us do the professional development with that, which is awesome. We created an edX course back in 2015, an edX course. We called it SPOC, a small private online course. We ran it as an edX MOOC for a year, and we had 16,000 people at one time taking our course, or at least signing up for our course. Not all of them finished. As you know, many of you know MOOCs are, a lot of people start and then very few people finish. This is a year-long course, one of the longest MOOCs that has ever existed. So because of that, very few students finished. 16,000 started, and I think about 200 or 300 finished. So it's very much a lot of drop-off over that whole year. But we were very happy to learn it, to offer the course, and very happy to have some very positive feedback. And now it was offered as a self-paced course. We are also, you saw that SNAP was translated to Spanish. We are also translating, traducido al español por Universidad Galileo in Guatemala, who is helping us translate BJC into Spanish. So we cannot wait. Our next year is going to be very big. We are going to be recruiting teachers, and we're going to have some conversation with our Chilean friends here. If we can, bring together some teachers. We're going to have, maybe you can be part of our teacher cohort, where the teacher is speaking Spanish, the language is Spanish, and the curriculum is Spanish, all in Spanish. So we are very excited about this opportunity. Thanks to, as I said, Universidad Galileo and Guatemala for helping us with the translation. We have students at Berkeley helping with that process. So I am really excited about this new initiative to bring BJC and Espanol to the Spanish-speaking world. Really, really excited about that, in which no student has to learn any English to learn computer science. That's the new space. I'm almost done. My second to last slide. My lessons learned. People often say, what did you learn from this? Teach me something. What did you learn from this initiative I've been doing for 10 years? All these teachers. Number one, teach in a graphical language. Our Chilean family knows that as well. It's very powerful to work in a graphical language. You definitely want to not be working in a text language for beginning learners. It's just so much better in terms of not having any syntax errors. Number two, you can teach powerful ideas to non-majors. That non-major course is called CS0. It means if you're teaching computer science to people at a university who are not going to be computer science majors, that's called the CS0 course. And you can teach very powerful computer science ideas, not just watered down intro ideas. Number three, consider a functional versus an iterative approach to coding. Many people think for loop, repeat loop, while. There are better ways to do this, and map, keep, and combine powerful ideas, and a functional approach is better. The data is immutable. All that is something that you should be thinking about rather than mutable data on for loops and while loops. Number four, bring computing in the news to every course to ground it. So every single lecture we give with our students, we have a computing in the news where we talk about a robot or a hack of data or a way that people are using cell phones in the forest to hear the birds. So there are different ways that computers are being used to affect society, culture, economy. And we want to talk about that every single class. And finally, celebrate a diversity of students. Don't make your introductory courses about weeding out students that you can't, that because you have some capacity limits, you weed them out. No, bring them in. Think about a big tent where everyone is welcome and everyone should come into your computer science course rather than pushing them away. And that's the lessons learned from my course. I'm all done. Gracias a todos. And I'm now able to take any questions, and I can also do a demo and show that if people want to see that, but I can pause now and take any questions. Thank you so much for the chance to give this talk, everybody.
Thank you, Dan. Andrea, do we have any questions?
Yes. Y aprovecho de recordar que por favor pueden dejar sus preguntas en la plataforma slide.do, que está en tv.inf.utfsm.cl, porque los comentarios en YouTube están deshabilitados, pero les invitamos a dejar sus preguntas en TVInf. Pueden ser en español o en inglés. Las podemos traducir acá, así que con confianza. So let's start with some of the questions we have in our Slido platform.
Oh, sure.
One of our colleagues are implementing the beauty engineering computing curriculum.
Wonderful.
And they are using a project-based learning approach. So they would like to know, what do you think about using project-based learning for teaching programming? And if you have any ideas about evaluating this kind of learning, especially related to creativity, how can you evaluate creativity in projects using Snap?
Sure. That's a very good question. Very good question. I'm a big fan of project-based learning. One of the things we do in our BJC course is at the end, we have an open final project where the students choose their own project. It's not necessarily project-based learning, but there's a lot of a project-based experiences, not just about learning and taking notes on paper. You're actually doing a lot of this programming. So I'm a huge fan of project-based learning. My understanding of project-based learning is that essentially the whole course is about building projects, and you don't actually ever teach anything. So people who go all in on project-based learning never teach anything. It's all just-in-time learning. So here's the project. Let's make a Pac-Man game. And then the student says, well, how do you make a sprite? And then you teach them how to make a sprite. How do you make an if loop? How do I make a decision in my code? You teach them if. So you would never teach them anything. You only do it on a just-in-time learning. And I haven't ever experienced that firsthand, but I have seen and I've heard very positive things about that way of doing things, because you're never teaching anything in abstract. You don't teach anything in abstract. You teach it only in the service of your project. So it's all driven by the project you're trying to do. We did work with Microsoft Teals, which is a volunteer organization to allow engineers and coders to volunteer in high school. And we made a project-based curriculum. So we took BJC and we said, what if we actually thought about BJC in a project-based learning model in which you had 6 different projects, 6 different games you were going to make over the semester. You made Mastermind and Pac-Man and the Worm game and Pong. And so they made different projects. And that was the whole goal. The goal is to make projects, and we teach you what you need in the service of making these fun projects. So that was not in the purest sense a project-based learning approach where you don't teach them anything and it's just in time learning, but it's basically thinking about this course is about building things and doing things and about these projects. And so that's one take on that, where you take BJC and you basically say, we're going to make projects after this. So I do love it. I think it's great. If you can make it work and you want to do a just-in-time learning approach, I think that's wonderful. In terms of evaluating creativity, I don't know. I think that creativity is maybe not something I would evaluate. Creativity just is, I would let creativity blossom in a way that says, don't tell the students what to do, but allow the students the choice to do things themselves. So meaning, in BJC, we have a final project. We don't say, choose from among a list of 5 things. We say, do anything you want. And the students say, I want to make a game or a tutorial or a data science thing. Whatever they want, the answer is yes. So in terms of creativity, I don't like to grade them on creativity, but I want to give them as much opportunity to have that creativity as much as possible. So in if you did project-based learning, make sure you have a lot of chances for the students to show their creativity. For example, as I told you, if I make Pac-Man and make the worm, the snake game, and make Pong, I'm telling you what game to make. I think it might be better to have the students choose their own project. So that allows for more creativity. So I would say creativity is not something I would grade. As much as possible, let them choose all the options. Give them the agency to choose whatever they want to do themselves. Thank you for the question.
Great. Then we have another question. Do you survey your students after after BJC, so to know what they want to do? For example, if they want to study more computer science courses, if they want to program anymore?
Yes, yes, and actually, we've done some data analysis on that too. We do it both informally. It's fun to watch them before the class ends. So the first day of class, you say, "How many of you want to go on in a career in computer science?" And some small percentage say that. And then at the end, you say how much, and it's like double or triple. It goes from 10% to 30, 40, 50%. So I love that idea that BJC has changed the career path of many, many, many students. In terms of overall, a lot of times our students don't have a choice because they come in as seniors. If someone comes as a senior in chemistry and they find my course, they can't change their career because they're already a senior. So the problem is, even if you were to look at it, it's really almost like you need to survey from the people who could change their life, who is changing their life. And thankfully at Berkeley, we have a philosophy in the School of Letters and Science, which means you get admitted to the school, but you don't have to determine your major when you first get to school. So it means you're an undeclared major. And so all of these undeclared majors who are taking our course, there's a huge number of them. I don't have the exact number offhand, but a huge number of the undeclared majors who are freshmen do end up declaring computer science because of BJC. So you really have to filter it by only the students who in theory could change their career path. But yes, we've had great numbers of students who come through, who eventually end up coming through our program, graduating and coming to talk to me at graduation and say, "Dan, you changed my life. I have a job next week at Google or Facebook or Apple. And if it weren't for you and weren't for BJC, I would not be where I am." And I'm like, I'm llorando and they're crying and it's so wonderful. So it's a wonderful experience when you have those students tell you that this changed your life, and it happens every single year at graduation. It's my happiest day. So yes, I haven't done a survey. I mean, we have done a survey, but I don't have the data in front of me to tell you what the percentage of students who do that, but it's a very good number who get hooked. They get hooked on it and they want to do more of it after. It's been very positive.
Talking about your students, how did you manage to attract diversity and women to the course? Did you advertise in some way? Was it a word of mouth?
That's a very good, very, very good question. So our first year, we paid some money. We had a very small budget. We paid some money to take out an ad in the paper saying, "Hey, take our course. This is a brand new course, doing it, blah, blah, blah." And then I surveyed people on the first day. How many of you saw our ad? Zero. Nobody saw the ad. So the newspaper, periódico, it was un periódico de ayer. Did not work. It was not something that changed anybody's mind. Basically, we started very small. Our first class, I can actually share our website. Our first class had 16 students, and the next class had 80, and the next class had 260. And basically, we told all of the students the first year, "Tell your friends." And then the next year, we told, "Tell your friends." We kept telling them the best advertisement is a student themselves who has gone through the course and likes it. And basically what started to happen, the reason we got our numbers up so high, all the sororities were, by the way, the women were doing better than us. The women are doing better than the men. I say us, the men. If I look at the GPA of women was higher than the men. Women, the average grade for the women was like an A, or A minus. The average grade for the men was a B plus. The women were doing better than the men. So they were enjoying the class more. They were doing better than on the final grades. And so basically word of mouth, it was all word of mouth through the sororities where people were telling their friends. And we kept saying at the end of the year, please tell your friends and bring a friend. We also, at the first week, this is also important. The first week we say, in the first 2 weeks, you can enroll our class up to 4 weeks. So for the first 3 or 4 weeks, actually, we told them, if you are alone in this class, if you don't know anybody, go grab a friend. So we encourage this of everybody. So everybody would go grab a friend and grab a neighbor and convince them to take the course with them, because we said this course has a lot of partner work. You work together in lab. You work conjunto in lab for the projects. You work together. So the idea was you encourage them to bring in their friends at the end and encourage them to bring in their friends at the beginning to get the numbers up. And that's what, and basically there's just momentum. Now, we don't do any more work. We do no more recruitment, and we consistently have the number in around 50% basically, up plus or minus. I actually did the recent statistics and I have the exact numbers. I can go find that. But yes, it's a really, really good number in terms of how well we've been doing for them. So word of mouth, encourage students who like it, make a very good experience for the students the first time you do it, and then encourage particularly all the female students to reach out to their friends to bring them into the class.
Okay, next question. We have seen some articles saying that women usually like computer science when they see it applied for solving problems, for helping their communities. But your course has also attracted Latinx and other minorities. What would you say it's the factor that attracts these other minorities to BJC?
Well, I'm gonna go try to find the actual page that shows you the numbers. We actually did some data analysis to find out how are we doing for women and how are we doing for underrepresented minorities in terms of Berkeley. We can't do basically, if you can get to the same number as the number of those students in your campus, then you're doing really well. Then you are representing your campus. And typically you're not. Typically every computer science, there's, I don't know, 20% underrepresented minorities at school and 10% minorities taking the class. So it's normally lower than that. We actually have done very, very well in terms of that. So we haven't done anything particular there about that other than in as much as possible, when we're hiring our staff, our student staff, we try to look for diverse candidates in as much as possible. We can't legally make a decision only based on gender, only based on race or ethnicity, but we can say, look, if two people are equal, you could pick the woman. If two people are equal, pick the person who's Latinx. The point is, if they're equal in your decision, you could lean on that decision as to try to increase your diversity. And by doing that, we have allowed our staff to be very diverse. And so once our staff is diverse, then they're telling their friends. Again, it's this whole positive cycle. It's a virtuous cycle, they say, in which people are telling their friends and doing that. And that's really very exciting. So it's been really great to see the growth of the class in terms of people adding and telling their friends about that, which has been wonderful. If that helps at all.
We have another question regarding your students after graduation.
Mm-hmm.
Do you know if people prefer to work in a company or teaching CS after finishing the course, especially now that teachers are needed to teach school children?
Sure. So what's interesting is basically everybody from Berkeley, when they graduate, goes into either industry to work as a programmer or goes to graduate school. Very, very few of them, unfortunately, very few of them go to be teachers, go to be kind of high school teachers. Some of them go to grad school to eventually be professors. That's fine. But very few of them take the option to go be teachers, which is really sad. We need more of the people to do that. Every once in a while, what we'll have is through the TEALS program, some of our former graduates who are working for companies, they will volunteer in a high school. So that you kind of get a benefit where you're bringing the expertise in, but not necessarily by being a teacher firsthand. I'm not sure if I have an overall, by the way, I found my graph. I'm going to show you my pretty graph if I can for a second. If I can change this and share this picture. This is the overall graph of the overall since we stopped doing the data analysis in 2019, but this is the 2019 numbers. We can see this. So the dotted line is the campus. And the dotted line is the campus, and the blue line, the pink line is the women, and the brown line is underrepresented minorities. So notice that this dotted line is around 15%. And notice we're ahead, and then below, and then ahead, and then below, and then ahead. So it's basically following and tracking the number of students in campus. And women, notice we started lower, but then we ended up higher, and then over here we're really high. So the point is we're basically tracking, on average over 10 years, we're tracking exactly what the number of females and exactly the number of URM students, percentage of students in our class. So we're really, really happy about that in terms of that. I'm glad I was able to find that data for you. But in terms of people going into careers, people are not typically going into careers in teaching. We wish more did that, but people are influencing the high school space by volunteering in high school through the TEALS program.
Great. We have a difficult time teaching for loops and while, and we see that you teach map and that sort of things. How are your techniques, and do you know if that knowledge it's transferred then to some text-based languages as Python?
Sure. Yeah. Certainly if the language has functions as data, then you can live in a map, keep, combine world. You can live in a world where you're only playing with powerful ideas. You're not getting stuck in a for loop. And it's always bothered me that so much introductory computing instruction, not blaming you, but everybody. I'm saying the whole world does this, where they spend all the time in a for loop, in a while loop, and you're getting there and debugging, and it's all low level. There's an analogy it's a beautiful analogy by the author of Snap, Jens Monig, who says, if you're stuck in a for loop and you're trying to get the variable to work and you're running out and the loop is not working, you're forgetting to update it and blah, 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 and you're not initializing it, it's like the analogy is you're in the mud with the pigs, and you're there and you're getting muddy and dirty there. But if you're flying with a high abstraction, you're flying with the birds. You're flying above all the mud. And so that's how I think of map, keep, and combine. If we're teaching, yes, BJC also teaches for loops and repeat until loop. We teach that as well, but we teach it and then it's a way. We don't give problems about it. We say that almost all these problems could be done two ways, and look how much easier it is if it's map or keep or combine. So we're really thinking about the higher level functions rather than the lower level, get stuck in the mud. You know, when I make an exam, I make 9 problems about map, keep, and combine, and 1 problem about for loops. My point is, I'm even emphasizing, I want you to be living in the upper space with the birds. Don't live down there. I'm not going to assess you down there. Most of the things you can do up here, you don't have to live down there. And the one problem I do give is the one problem that's hard to do map, keep, and combine, and it's easier to do in the for loop. So I'll find 1 out of 10 problems that a for loop is better and ask about that one. But 9 out of 10 problems, if you live in the upper world. And by the way, it translates beautifully to Python. And at Berkeley, our next course for majors is in Python. So we have 5 weeks where we take Snap and teach them Python if they know Snap. And so the students, and I can probably find a slide that I can show you, which is like, here's how you do it in Python, in Snap. Here's how it's in Python. It's exactly the same thing. It's a really beautiful kind of lecture. So we already help our students with that translation, with that connection to the other languages.
Great. I think we are just in time, Federico, aren't we?
Perfect.
Okay.
Yeah, I'm looking at that too.
Thank you. Once again, Dan, thank you very much. It was really great to have you here. Really fun. Almost like taking BJC. We hope to see you soon.
Wonderful.
Thank you very much. And muchas gracias.
Igual, un placer. Wonderful. Thank you so much. Thank you so much.
Muchas gracias a todas y a todos quienes nos acompañaron hoy, y van a poder revisar la grabación también en caso de que no hayan podido seguir la velocidad de Dan, que es bien acelerado y sus charlas son muy, muy emocionantes. Muchas gracias a todas, a todos. Nos vemos pronto.
And we're going to be on in conversation as we start talking about BJC en Español and doing professional development in Spanish next year. So let's make sure we keep in touch as we have our curriculum coming together.
Okay.
I'm really excited about that.
Sure thing.
Wonderful.
Bye-bye.
Can't wait. Good to see you, folks. Thank you so much.